Hey guys, today we'll be doing lead code number 881, boats to save people. This is a medium question. So let's take a look at the question first. Okay, so we're given people, right? We're given an array people, 1, 2, 1 being the weight, 2 being the weight, right? Both of them correspond to weight. And we're given a limit. So in this case, we were given 3, right? And we have to essentially load up as many boats, like we need to calculate the number of boats needed to fit the people in. So limit equals to 3, a boat has, so the capacity, right, the in this case it just means like the weight has to be less than or equal to limit for a boat to be counted. Okay, so what do I mean by this? When we do 1 and 2, when we add the weights of the two people, and there's another rule, 2 people only, right? So 1 and 2, we get 3. 3 is less than or equal to the limit, right? So we would count that as one boat. Okay, and it already fit 2 people, right? Fit 2 people, and that was the entire array. So one boat, that's all we needed. Now let's go to this one, 3 2 2 1. If we look at this, we will see, if we just count the number of possible boats within 3 and like optimize it, then you will see 2 and 1, then you will see 2, then you will see 3, right? Now what if I, okay, so I'll get to the solution now actually. So what if I had, so right now it's very hard to like, I mean, we can visually see that, okay, 2 1 2 3, that's it, and then we will see limit, and then that's it, right? But how do we determine like the index at which we will move? That index is actually relevant, as in it is the most optimal choice. The best way actually, so if you have come across 2 sum 2, it is the same exact logic, because what you do is you sort the array. So you get 1 2 2 3, and all you do is you check with your left, you check with your right. 1 plus 3 right now, we see that that's greater than our limit, right? So it doesn't fit the one boat can be sent out scenario for this, right? And when we can't send it out, we will just consider the right to be a boat. Like we will say, okay, be a separate boat, and we will now consider 2 and 1. We'll move our pointer to 2 now, and then we will go and check, okay, 1 plus 2, that is actually equal to the limit, so now we can send a boat out, right? And then when we are at 2, we'll see that essentially we will move left and right inwards, right? Because now we have to consider a new pair, and then we'll see that, okay, the only thing is 2, and 2 is less than or equals to 3, so we can send out a boat immediately. That's completely fine. Doesn't have to be 2 people, right? Can be 1. So that's the whole idea. We sort it, and then we use the left and right to essentially just check, is the weight greater than or less than the limit. And to write this out in code now, I'll just do people. We will first sort the array, right? Now there's 2 ways to do the code itself. I'll show you the most clean way. So this is how we put the left pointer, right pointer, such, and then counter for the number of boats, right? Up until these 2 cross each other. Okay, once these 2 cross each other, we've already completed counting the number of people, right? So this would just be invalid. I'll say weight is equals to people left people right. Then if weight less than or equal to limit, in this scenario. Then like I said, we will move it inward because we've seen a pair, right? So now we don't want to consider that pair again on either end, so we will just do left plus equals to 1, right minus equals to 1, move it and shrink the array, and we will send out our both. In the case that it is greater than the limit, right, so we've already considered less than or equal to, now we will just be greater than, we will send out the right individually. But before we do that, we will also say move the pointer back so that we now consider a value that's less than the current, right? It's kind of like the 2 sum 2. If you want a better explanation of why the 2 pointers move around, you can look at 2 sum 2 as well. Then counter plus equals 1, we send out the both. At the end, we return counter. Okay, so the next version that I was saying was, if you just had the loop be val L is less than R, you could have that, and then when, if you see that at the end, if L is equals to R, that means there's 1% remaining, you can simply just increase it by 1 and then return the counter. The logic in the inside the while loop stays the same, exact same. It's just there's one final check before you return the answer. But I would say this is much better, right? Cleaner.